Hey everyone, another day, another DSA problem. So today let's look at 3020, find the maximum number of elements in a subset. So this is today's daily problem and it's marked as medium. So let's just go ahead and see what they're asking us for. Okay, so it says that you're given an array of positive integers, nums, and you need to select a subset of nums which satisfies the following condition. And basically what the condition here is, you have to go from x to x squared to the square of that, and then you have to like go back down. Like if it was a mountain and you were going in increasing order of squares, you have to be able to go in the same decreasing order back again. So let's just look at an example to kind of understand this better. So let's see the one they have given here. So 5, 4, 1, double 2. So if we check in this, we can actually use 4, 2, and 2 to form 2, 4, and 2. So it's going up 2, square of 2 is 4. And then again, it's reducing again, like the square root of 4 is 2. So if we had another number, let's say if it was 2, 4, and then square of 4 is 16, and then we have the square root of 16 again is 4, and then 2. So that's basically what they're asking us. So if we form that mountain, what is the length, the maximum length of such a pattern that we can form? So yeah, that's basically what the question is asking. And let's just kind of understand this better here. Okay, so like I mentioned, the question states that we have to find the longest pattern that looks like x squared, x raised to 4, and then so on and so forth, but then it goes back down in the same way that it went up. So in this case, like I said, we have 2. Then we have 2 squared, which is 4, and then we have 4 squared, which is 16. And so we have used this, we have used this, we have used this. And then square root of 16 is 4 again, square root of 4 is 2 again. So, well, you look at that, we have formed a mountain. And what is the size of this? So it's 1, 2, 3, 4, and 5. So the answer here is equal to 5 because that is the maximum length of the pattern that we can form. All right, so if we look at this example, and basically the whole question that they're asking us, we can come to a few observations, right? So if we look at this one right here, we see that every number except for the one over here had to be present twice so that it could contribute from both sides to form that that mountain, right? So we needed 2 2s, we needed 2 4s, and then we need a single peak element. We can have more, but we need at least one peak element, right? So if we want to write down these observations, that would be every number except for the middle number appears twice. And the middle element appears once, at least once, actually. So we have to look for such a pattern where we can find this, and then we can get the maximum length, which follows that pattern. So the goal becomes find how tall of a mountain we can build, which follows this required pattern. Okay, so looking at the example that we just saw, we saw one thing. We needed those elements to the side to have a count of at least 2, right? And then we needed that peak element to have a count of 1. So one thing we're sure of right here is counts matter to us. So because the counts matter to us, let's go ahead and record them. All right. So we'll have like a frequency dictionary where we're mapping the number and the count, which is very important. So let's look at 2. We have 2 2s. So the number is 2 and the count is 2. Let's look at 4. We have 2 4s. We have the number 4 and we have 2 counts of that. Then we have the number 16 and we have 1 count of that. And let's just keep this handy throughout the problem because we will use that. Now, what we're going to do is, because we don't actually know what the starting element of that sequence, that pattern we're going to get is, we're going to try every number as the starting number. All right. So here in this the array that was given to us, we're going to start with 2, right? So our current element is going to be 2. Then I'm going to check, hey, if this is my start, then do I have more than 2 counts of 2? And then I check over here. The count of 2 is 2. So yeah, this works. And I can start building, right? At least the base of my mountain, I have 2 2s, which are ready over here. Then I'm going to go ahead and find the square of 2, right? So it'll be current into current. So that is 2 into 2, which gives me 4. And now I'm going to go and check, hey, do I have at least 2 counts of 4? And great, I do. So this is going to be the next layer of my mountain. Okay. And then I'm going to do 4 into 4. So current is going to get updated to become 16. And then I check, do I have 2 counts of 16? And no, I do not. So that cannot be like another full layer. It's going to become the peak. So in like programmatically, this is how we're going to check it, right? As long as we have 2 elements, which can contribute from both sides, we're going to keep checking that. And we're going to keep on increasing what our next peak element should be. And every time, because they're adding 1 element here and 1 element here, that is adding 2 to our total length. So I keep adding that. And yeah, now we have 4, and now our current has become 16, right? So the question is, what happens when we go to 16? So yeah, I just explained why the length is +2. And once this while loop ends, we have 2 possibilities, right? It can be that there is 1 copy of the current element. If there were 2 copies, it would keep continuing. So it could be that there is 1 copy of the element, the current element, right? So current is equal to 16. And in our case, we do have 16. So we want to use that as the mountain's peak. And we know that there's only 1 count of that, right? So we're going to do a length plus 1. So our total length, we got 2 from 2, the second, this layer, which had 2, and then we got 2 from that. So it was 2 plus 2, and we have a plus 1 from our 16. So we have a length of 5. Now let's take the condition that our array was only like 4, 4, 2, 2, and we never had that 16, right? So I would have formed a base, which was of 2's here, and then the next layer would have been 4 and 4. And then my updated current would have become 16, but I see that I don't have 16 at all. So when no copies exist, one thing I can do is from the construction of the mountain that I just made here, if I just reduce, like if I just delete 1, 4, then if you look at that, I still have a mountain which follows the row, right? So in that case, we just trim down the mountain and make the previous level the mountain's peak. So we want to go ahead and decrease our length by 1 because initially it was 4 and now we subtract 1 and we have 3 and that's still our mountain here. Okay, that's basically the whole problem itself. So there is one special case though. So when the number is 1. So let's look at the pattern of 1. 1, 1 square, 1 raised to 4, and then back again. Everything is the number 1 itself. It doesn't change. And if we want to form a mountain, basically we can take all the ones, but we'd have to have like an odd number, right? So let's say we had 1, 2, 3, 4, 5. That does form a valid mountain. Okay. So if I have an odd number of ones, if they're an odd number of ones, just use all of them. Okay. So I have 5 ones. I'm going to use all 5. Now, let's say there was an even number of ones. If that case for odd doesn't fulfill, let's say I formed 1 layer, I formed another layer. The same thing that we did earlier, we're going to remove 1 over here, and we're going to still make this a mountain. So we need an odd number, right? So we're just going to return whatever frequency of ones there were, which is an even number, because we check here, subtracted by 1 to make it an odd number. And that would be our length, right? So we'll use that, and then we'll check the rest of the numbers. Okay, so let's check the complexity of this. The time complexity is actually OFN. I know it seems like we're going in a loop and then we're checking numbers again, but consider it. For every number that we consider might be the first number, we're going to go and inside that loop, we're actually going and squaring it each time, which grows very rapidly, right? So it grows so fast that it's very negligible and we will reach like our maximum element already. So that doesn't really contribute much to the complexity. That's why the time complexity is O of n and the space complexity is O of n as well. So this O of n comes from the frequency map as well as like checking each number as like the valid one. Okay, and then space complexity is because of our frequency map again. Okay, I hope you guys understood this. Let's just go ahead and check out the code. All right, so the first thing I did was I kept a frequency map, right? So I'm going to go through every number in nums, and I'm going to do frequency of number is equal to 1 plus whatever the count previously was, number, comma, 0. Okay? And then basically at the end of this, we want to return an answer, which has to be a maximum. So we'll keep answer as 1 because let's say there was only one element, it would have still satisfied this rule because it starts from x itself. So by default, answer would be 1. And I think we're guaranteed that the size, okay, size is obviously, it's going to be greater than that. So answer is 1 could be valid. Now we wanted to check our special condition if 1 was present, right? So if 1 is in frequency, then I can go ahead and check how many times 1 has been repeated, right? So I'll do if frequency of 1 is an even number, then I know answer is going to be equal to frequency of 1 minus 1 because we need an odd number of ones to form a mountain, or else answer is just going to equal frequency of 1. Okay, so now we have sort of covered that condition. We can go ahead and try to look for all these other numbers and see which gives us the maximum pattern length. So I'll do for number and nums. I just checked 1, so I want to consider that as well. So if number is 1, let's just continue. Let's go to the next number that we have. Or else I am going to make this number the current number. So current would be equal to number and our length is equal to 0. So let's just form the length of the mountain and let's see from there, right? So as long as we have 2 elements, we're building the mountain, right? So I want to check that. So we will take a while. So while frequency dot get number, because current is going to get squared each time, that might not be there in our frequency or in our nums at all. So that we want to do get that current or 0 is greater than or equal to 2. Then I know that it's actually forming the mountain, right? So I want to do length plus is equal to 2 because it can add from both sides. And current is going to get squared. So for our next iteration, it will be the next square of that. So by this point, I have a number which is supposed to be the peak. So I'm going to check if that peak actually exists, right? So I'm going to check if whatever that was, frequency dot get current comma 0 is greater than or equal to 1, meaning it exists. So then I will add that as the peak and increase my length by 1. Or else, if it doesn't exist, then I want to truncate the mountain that I had, right? So I want to reduce it. And we will do length minus is equal to 1. Then we can go ahead and do answer is equal to maximum of whatever answer we had and the length. And yes, at the end of this, over here, so I should be able to return answer. If I haven't made any typos, this should work. Let me just write the time complexity over here. It's O of n, and then we have space complexity, which is also O of n. Let's try running it. Okay, it's working. What did I do wrong? Oh, sorry. I forgot to write a 0 over here. I don't know how I did that. Okay, great. So it's working fine, and I hope you guys understood it. Sorry for my mistake over there, but yeah. Happy coding, everyone.